Engineers, India, and the Indian Society for Technical Education, etc. He has authored or co-authored or published more than 60 plus articles in journals as well as international or national conferences, two books such as Automotive Tribology and Tribology in Materials and Application in Springer, and Engineering Thermodynamics for UG level in Khanna publication. He is active reviewer in various reputed journals such as Tribology International, where Polymers, Defense Technology, Collides, and Interface Communications. Journal of Materials Research and Technology, Materials Research Express, SN Applied Sciences, Engineering Research Express, International Journal of Surface Science, and Engineering Friction, Journal of Engineering Tribology, Part J and Silicon. He has delivered more than 15 plus invited talk on various research fields related to tribology, composite materials, surface engineering, and machining. He received the research grant from various government organizations such as MHRD and SCRB. And we, on behalf of Aeronautical Department, MLR Institute of Technology, Hyderabad, welcome the speaker, Dr. Jitendra Kumar Katiyar, sir. Thank you for your session, sir. And you can hand over the session, sir. We welcome you.
Yeah, thank you very much for such a nice introduction. And now I'm going to share my screen. Please check either it is visible or not.
Yes, sir.
It is
Yes,
visible?
sir. Yes, sir. Your screen is being shared. You can carry on, sir.
Okay, okay. Now this full screen is okay?
Yes, sir. Yes, sir. Now it is okay.
It is moving forward also?
Yes, sir. Yes, sir. Yes.
Okay, thank you. So, very good morning to all of you. And I'm mostly thanks to Dr. Gupta who give me such a nice opportunity to interact further to all participants in this event. And I just share my thoughts on the composite materials for various engineering applications. In this, mostly I will focus on the first I focus on the history of the composite, and then I just basics of the composite. How this, what is the basic definition of the composite? What are the different components in the composite? Then various classification, and what is the current trend in that particular era, in this era. And then we slowly move to the nanotechnology aspects, and because we basic AICT, this webinar is nano composite material. So nano composite, we just touch upon this nano composite, and then whatever one case study I just show you, that particular done by the my doctorate student, and then I will show you the different applications of these nano composites. And then at last, that I also wants to emphasize the flammability test. That is also very important when you design any composite material for any structural application or some commercial application. And then at last, another case study I will show you the regarding this nano composite, which is used in metal mattress composite material. So like regarding in the application of your automobile engineering. So this is my basic content of my talk. So just move ahead. So begin with the history. This is a composite, it not comes now. It is a previous age also, even though in Holy Bible it is written that Israelis in Egypt added a straw to mud when making the bricks. So they just whatever the bricks you are seeing, that all are composite material. And in the medieval time, sword and armors is also made up by the composite material. So this is, you can see these are the Chinese bows. And in this Chinese bows, you can see before string this composite, and after strung, how it looks like. So this is composite is very flexible that in that particular era, and you can snatch it, and then whatever the force you want to apply it, and then release it that particular string, and it according to your applied force, it your bow will move, arrow will move further distances. So that is the in Chinese bow in 10,000 1000 BC. And then natural fiber composite is also used in that particular era also. So that natural fiber composite is basically he is taking they are taking from the our trees, because this natural fiber composite consisting of the cellulose microfibrils and encapsulated in a lignin matrix. So this is the particular classification inside the tree. When you cut the tree part, and then you can find out this cellulose is present, which is encapsulate the lignin matrix. And so here, basically in composite material, in further slides, we look the basic two component is there, matrix and reinforcement. And the importance of both component is very important in composite material. So this slide gives you the more about the how the material is evaluation happened in the material in year by year. So in and what is the importance in y-axis? I just plot the importance of the particular material, and then in x-axis I just plotted the year. So you can see here in 10,000 BC, in our BCAs, we just have the 3 or 4 material, not more than that, like gold, copper, bronze, and iron. And initially, the polymer matrix was the only wood and skin fibers that our body is there. So, and composites basically straw wicks and papers only they have made by adding the some particle mix two components, and they can make the composite material. And then in case of ceramics, only stone, poetry, glass, cement. These are the just after BC. When you come into this our era, 1000 AD or 2020, you can see here our basic new types of the polymer, biocomposite polymer, or some this PMMA based polymer composite, metal matrix composite, or glass reinforced fiber composite, carbon reinforced fiber composite, all are developed in this our 1980 to 2020. And in ceramics also, they have just in 1940 they just make a cement, and that is widely used in a construction purpose. That is types of the ceramics. And in metal also, they nowadays, even though super alloys, smart material, and other things are already evaluated, and they just perform in various they just used in various applications. So presently also we are working on the lithium, aluminum lithium alloys and dual phase that is used in basic electric vehicles in batteries. So this is from this picture, you can easily identify that the era in which era we are working and what are the material in the previous age it was there. So in polymer case, up till 1940, very less amount of the polymers evaluated, this investigated. So that like bakelite, nylon, or polyethylene. And then nowadays you can see that PMMA, polyester, high modulus polymer, high temperature polymer also, because the main disadvantage of the polymer, it is having a very less uh, temperature, thermal gradient. So our main aim is, if we are using the polymer composites in any application, then we just increase the thermal stability of that particular composite material. ceramics are also used, but the problem in ceramics, it is a very not a very lightweight based, and we can't use in several applications, but it is good in a wear resistance and other properties also. So in like this super alloys and titanium, zirconium, nowadays new alloys, new metal alloys also investigated by some researchers. That is a highness 25 to highness 16. These are the grades of highness 16. This is the cobalt based, cobalt and niobium based alloy, which is further used in a space application and other things. So if anybody wants to work in this area, then you can choose the highness 16. This highness 16 is costlier nowadays. One feed rod of 25 diameter, you will get is approximately 18 to 20,000. Uh, this is a
It's 12
new
o'clock.
material. So when we move further, what is the basic definition of the composite material? So we have the one interface, we have the matrix, and then we have the reinforcement. So that reinforcement may be a short fiber. This is a types of the fiber, different types. Either you just add the short fiber, long fiber, or you just add a particulate or whiskers, whatever type of the reinforcement according to our applications. So this composite material is nothing but we just add two or more distinct material and produce the synergistic property of that particular parent composite material. So when you define any composite material, you have a two or three component. Each is having a different properties, different physical property, different mechanical property, different chemical property, and several advantages also. So what we'll do, we just add it and use their advantages in what advantages it is having. Like in a metal cutting, we are using this CBN tools or some other composite tools also. So we just added the particular several element in that particular making of the super alloys. So that is in a material case, a metal matrix composite. That is the thing. So in this, when you talk about the composite material from this same image, you can easily identify that. So what is the matrix? Then in this is a matrix. Either this is a epoxy or some other means cement, whatever you want. That is a matrix. And then this is a fiber. This may be a long fiber or short fiber, which you'll see in further slides. And this is called a interface, which is having a highly adhere with the matrix, so that whatever the force uniformly distributed matrix and this fiber or reinforcement, it supports the matrix. That is the main function of the matrix and reinforcement. And then further you can easily define another way also. When you when you mix the set of material by physical means, so you can produce the one single bulk without any physical blending. So the resulting material is called a composite material. So you just add the different material of different physical properties and you will get a better material than the parents material, or single whatever the property of the single material, you will get a better properties of the composite material. So there are several advantages of fabricating of composite material. Like they can usually exhibit the best quality of their constituent, whatever the constituent you are using. So parent constituent, the composite material shows the better quality in that particular material. And then two most important advantages of the composite material is it is having a high strength to weight ratio and high stiffness to weight ratio, so that you can save your weight. So that's that, because of that reason, the in aerospace industry the composites application is more. So often the composite material are constructed at the same time and the produce unlike other common engineering material. And due to fabrication, this integration of the parts, you can achieve the good surface finish, from this you can reduce the wastage, and also you can reduce the manufacturing cost as comparison to the other material. These composite material, when you mix two or three constituent, and then it will give you the better fatigue property, better thermal property, better impact property, better tensile property. So all types of the mechanical property, it will show the excellent from their parent constituent material. So thermal and acoustic insulation benefits is also there. So after fabricating the composite material, the thermal stability is also increased. So you just add the material in such a way that you will gain that particular thermal stability, because in polymer, every polymer like polypropylene or thermosets, thermoplastics, or whatever, there are two categories like thermosets or thermoplastics. So mostly polymer composites or carbon fiber reinforcement composite, there also we use the epoxy as a matrix. So in that particular cases, the pure epoxy is not more than 180 degrees centigrade. That is the thermal degradation of that particular epoxy material. So you just select the reinforcement in such a way that you can improve their thermal property also. So basic composites, whatever you have fabricated, at least it can show the better thermal stability rather than their constituent material. But the few disadvantages of the composite is also some, it is a very high cost when you mix more constituents in that particular one. Also it is anisotropic behavior, because the your properties are changing according to that particular one. So that's why it is a heterogeneous in nature, not in a homogeneous nature, because each and every slice gives you the different density, gives you the different property. So that's why it is having an anisotropy behavior, not isotropic behavior. And also it is a sensitive to humidity and sensitivity to the stress concentration also, because sometimes what will happen, the some places you can get a more stress, uh, but as comparison to the other uh, cases. So also till now in this we are living in the 2020 era. Till now the total means fully matured testing methods in composites are not developed. So this is also, it is still the research point of view. You can say that it is a beneficial to us. You can at least produce and set a one best research method through which you can get all properties and all those things. So test methods are still, it is undergoing research. Which test is best? It is still not decided. Like it is best 3-point bending for flexural test, 3-point or 4-point, because people are doing sometimes both, sometimes one. So that is the thing. So which one is the best? Nobody knows, because that is a uh, but they have set up the methods, they have produced it, and they have you can find out in the various literatures. So move to the classification. As I told you, there are basic two types of the composite material. Either you can classify based on the matrix, or you can classify it based on the reinforcement, whatever you are added. So in base of the matrix type, so in matrix type there are further, it is three types: either your polymer matrix, metal matrix, and ceramic matrix. So in polymer, there are two types of the polymer we are using: thermosets or thermoplastics, and we all know, I hope, basic difference between the thermoplastics and thermosets. In metal matrix composite, these are also used to fabricate the like brake material, brake liner, or other things. So these are the use the metal matrix composite for high speed cars and Formula A's. We generally prefer the metal matrix composite brakes. So this is the one application of that particular metal matrix composite. And in ceramic metal composite like glass or cement type, that cement is widely used in our construction purpose, glass is also used. So that is a matrix. And according to the reinforcement, what type of the reinforcement we are adding, either fiber we are adding, either we are adding the particles. These particles may be micro, macro, or nano size. So if we add the nano particles in any composite in matrix, then that type of the composite is known as a nano composite. So don't confuse in this nano composite. Only one constituent in a nano level in that particular composite. So that's why it is known as a nano composite. So means we just add the nanoparticles size of the few nanometer, then that composite name as a nano composite. So either you can use the whisker type reinforcement or particle like micro, macro, and fibers. As I told you, either you can use the short fiber or long fiber or random fiber, unidirectional, bidirectional. There are several types of the fibers is there. In nature is also present so many fibers. So that is called a natural fiber or synthetic fiber also it is there. And what type of the structure you want to manufacture? Either you want to a laminate structure or you want to a sandwich type structure. So these are the few classification of your composite materials. So you just remember that only two types of the classification, and then further it is subdivision is there in these two types of the classification. So fiber reinforcement composite, like there are binders and reinforcement. So in binders is the component which that holds the reinforcement together to form the bulk of the material. So this binder may be epoxy or some other means, so that you can or you can see in home the concrete that your cement is a binder, and other concrete and other things it is used as a reinforcement. And reinforcement is the component that provides the matrix or binders strength, stiffness, and other advantages. So binders takes the complete load, and your reinforcement supports the binders. So in case of short and long fiber, how we can decide this is a short fiber, how we can decide this is a long fiber composite? It is basically decided by the length to diameter ratio. So if your length to diameter ratio is having approximately 100, then that is called a short fiber composite material. While your if your length to diameter ratio is infinite, tends to infinite, then that is called your long fiber composite material. So means if greater than 100, then all types of the fiber is known as a long fiber composite material. But if length to diameter ratio is your means tends to 100, then that is called your short fiber. So it is infinite means your diameter is means much tends to the zero, means you are reducing the diameter of that particular composite. So in that way it can tends to the zero, infinite. So two terms are widely used when you manufactured any composite material. So one is called a lamina and another one is called a laminate. So what is the meaning of lamina? Lamina is the just a single layer, and here your fibers are oriented one direction only. So these type of the means fibers, if it is oriented in one direction, then that is called a unidirectional composite material. So another terms, as I told you, laminate. So it is a typical fiber reinforcement composite material which consists the multiple layer. So one single layer known as a lamina or lamining, then you just staking 1, 2, 3, 4, 5 of all lamina. So more than 2 or 3 lamina consist a laminate. So this sometimes this laminates are also known as I told you, the piling of that particular laminas. So fiber resin composite matrix bonded together to construct a laminate or piling of 1, 2, 3, 4 and different orientation. So here what is the basic observation in laminate? So fibers in each of the layer is usually oriented in a different direction. So that's why it is a multi-directional composite, because each layer having a different orientation, different directions. So, but the layers, whatever you use, that is a unidirectional. But piling of the different layer at the different staking sequence, that is called a laminate. So their direction is multi-directional. So in case of making of any composite material, we need the two. One is called your matrix, one is called your fiber. As I told you, fibers are two types, natural fibers or synthetic fibers. So synthetic fibers like glass, carbon or aramide, and natural fibers like wood fiber, flax, jute or hemp. So nowadays, natural fiber are widely used, and that type of the composite is known as a green composite, or sometimes it is also a biocomposite material is also using the natural fiber. In binders type or matrix is mostly in polymers case, the thermosets or thermoplastics. So here you can see the different fibers and their properties. I just compile it all the fibers with their properties. So different, these are the synthetic fibers, carbon, aramide or e-glass. And you just remember from these table, you can easily observe that whatever the synthetic fiber, the strength of the synthetic fiber is good, but that is also means harmful for the environment and other aspects also, not biocompatible and other things, but strength is good. So and you can see the carbon is having a greater strength in case in terms of the strength modulus, density also, density sometimes. So what we will do, and these are the natural fibers like pineapple, sunhams, coconut, jute, and you can see here the properties of their physical or mechanical properties. Both are lower than the synthetic fibers, but these fibers are good, environment friendly. So what we will do, we will see in next slide. So matrix also, the various types of the matrix is used, either epoxy based matrix, PEEK, polycarbonate, polyurethane, rubber, aluminum, magnesium, titanium. These are the metal matrix, making a metal matrix composite. These are the polymer based composite, and borosilicate, that is used in making of the ceramic based composite. So when you fabricate the composite material, so according to the matrix, so either it will be a polymer composite, polymer matrix composite, PMC, or metal matrix composite, MMC, or ceramic metal composite, ceramic based composite. So this different types of the matrix we used according to our purpose, what application we are focusing. According to the application, we generally focus in the fabrication of the composite. So mostly in polymer case, we are focusing on this epoxy based, or sometimes we focus on this polyester. So these are, polyester is also a thermal expansibility is good, this 150, and density and other things is also good. But in case of this PEEK is also used, but that is not by application. So mostly laboratory scale, when you want to do perform some experiment, then epoxy based is used. So this aluminum or magnesium or titanium, these are the metal matrix composites. So titanium is widely used in the in brake materials, in for this speed formula race cars and other things, because it is having a good thermal property and also a good young modulus and also good density. So this titanium and magnesium is also used. So if you use the magnesium, that is called your lightweight composite material, because magnesium is a very light, it is having a very light weight. So this magnesium is also nowadays people are trying to reduce the strength to weight ratio. So that is the that magnesium particularly used in metal matrix composite nowadays. So how you can select any matrix, what are their desired characteristic, that is very important. So you can see here the according to the mechanical and thermal what you want, either you high strength, high elastic elongation, high modulus, you need a low creep, because what is the creep? When you deform the permanently any surface for some duration, then what is the permanent deformation occurs? So resistance of that particular permanent deformation is called creep at constant load. And then you need a high toughness, you need a low thermal conductivity. So these are the few mechanical and thermal desire when you choose the matrix composite. Other basic important is it should be a low cost, low density, and low dielectric constant. And in terms of the chemical properties, should be bond, better bond between the fibers. So it will behave so nicely when you mix some fibers in that particular matrix, and it can at least bind that particular fibers with their matrix. And also it is matrix should be a low moisture absorption, it should absorb very low. And these are the few processing characteristics when you fabricate, like at least it should be a good flow characteristic, so that whatever the cavity is there, it can easily fill that particular one, and then you can fabricate the desired shape of that particular composite material. So current situation is we just defined by this picture. So x-axis is we just defined the specific strength, and y-axis we just defined in the specific stiffness. So if this is the present situation here, we are here nowadays, like we are using polymers, polyurethane, foam-based composite material is also used in packing purpose and other purposes. Uh, Foam base is also absorbs the vibration too much, and other properties is good in foam based. And wood products are also like a composite. Here you can see this as here. So right nowadays we are here and we want to move that some composites which is a biodegradable composite, and uh, other aspects through which we can at least improve their strength to weight ratio, and also it should be a good stiffness to weight ratio. That is our main aim in current situation. So either we are working in aircraft, or we are working in aerospace industries, or space industry. So the chamber, how you can make with a lighter weight, and it should be have a good stiffness to weight ratio also. So that is a desired nowadays. So our presently we are also having some biodegradable composites like UHMWP. That is a uh, composite which is used uh, widely in a coating purpose of the hip and knee joints over the titanium. So our future is here. We just move into the moving to the natural fibers, and we just mix with the natural fibers in the matrix like Kevlar, aramide, or some NAF fiber. We just mix it in that particular one, and we can increase the particular mechanical strength as well as the physical properties of that particular material. So as I told you, natural fiber is very widely used nowadays. So you can see from this market of that particular natural fiber composite, it is growing drastically. So this natural fibers, 70% natural fibers are used in our building products, 15% only in automotive industry, and 8% is making for infrastructure, and 7% natural fibers like some other purposes like sports and other goods. So if we use the natural fiber in that particular matrix, so it is having so many advantages rather than the disadvantages. So it is a low specific weight, processing is user friendly, it is not harmful to the human, good thermal and acoustic insulation, also low cost and possibility of thermal recycling because these are generated from the environment. And it is also having a renewable resources or also biodegradable after some time when you want to degrade. Disadvantage is enormous variability in that particular natural fiber. So each natural fiber is having a different properties, and sometimes it is a poor moisture and fire resistance, and it is having a low durability and lack of fiber matrix adhesion in some cases. But the natural fiber products are widely available in the market, and these are the few examples of your natural fiber products where we use that particular natural fibers to making the construction of any building, construction of boat, and here also we use some natural fiber composite fibers to fabricate the guitar and other things. So main funda in this era is our environment friendly material. So as you seen that particular one, these are the matrix material, which is I showed you in a few slide back. So in this, these are the synthetic fiber and these are the your natural fiber. So how you can correlate or optimize so that you will get a better mechanical and physical and chemical properties. So that is the basic thing mostly used in research, that epoxy glass fiber that is widely used, and with some flax and pineapple sunhaps this is used for bobbin fiber. So these are sometimes so many persons are also research on the sisal jute fiber. So in this composite era, you have a lot of research scope. So how you can vary the matrix, how you can uh, vary the reinforcement according to that. You just uh, did your you do your research. That is so much scope in this area. In this material science, this is a kind of a material science where so much scope is there. Only you know how to play with the material. So natural fiber selection is also very important when you select some natural fiber. So material which has got lower impact on the environment with having good mechanical and fire properties. So when you select any natural fiber, you just check the limiting oxygen index. If greater than 18, then you just select that particular natural fiber. If it is less than 18, then don't select that particular natural fiber because it will not give you the better thermal stability and other thing, other properties also. So when you select that particular natural fiber, you can see I am here written so many natural fibers and their density and tensile strength. So mostly flax is used. After flax, this nap fiber and then cotton fiber is also used. Then sisal or hemp fiber. So this nowadays flax or canaf fiber or hemp fiber, because of their tensile strength is good, young modulus is good, also it is having the percentage of moist absorption, and also price basis it is very cheaper. So this is the first criteria to select which of the particular natural fiber in that particular uh, composite material, in fabrication of composite material. So you just check in a laboratory what is the limiting oxygen index. That is the most important criteria. It should be greater than 18. So this kenaf fiber, it is the kenaf tree is there. So most widely it is found in that particular hilly station, hilly areas. So this is the structure of kenaf fiber. It is had lumen and then lignin, hemicellulose. So when high lignin content in that particular kenaf, if it is there, so it promotes the char formation and also resists the some thermal barrier. So it is having basically kenaf fiber having the cellulose of 40 to 57%, hemicellulose, lignin or S. So that's why this canna fiber is widely used apart from your flax fiber or hemp fiber. So up till now, just I show you the different basics of your composite. What is the laminate, laminin, and then now we move to the further next current trends in that particular market is nano composite. So before going to nano composite, I just want to define what is the nanotechnology, and this nanotechnology is just a scale, and this technology which deals with the materials or particles in a nano size. So in the when you fabricate some component, what is the micro, what is the basic difference between micro and macro? So in that, so sometimes so many persons confused. So any one dimensions, either in a micro, then it is called a micro component. If one dimensions, if any one dimension is having a nano, then that is called a nano material or nano this materials or composite, whatever you can say. So this is the evolution of that particular scale, how we can define each and carbon nanotubes or cellulose nanofibers. Then this is called MEMS, micro electromechanical devices, which are very crucial and widely used. And here so much of the travelogical behavior. When you move in a nano scale, then adhesion properties is increased, so that the friction on the surface is also increased. So that is also, you just take care when you move smaller, then adhesion is also increased. So van der Waals forces is also improved. So because of that reason, this nano travelology is very important in these aspects. So travelology is nothing but a study of friction and wear in a various environment. So it is nano size means like atom level, or you can percentage surface area in proportional to the total volume which is compared to the materials in the bulk. So that is a nanotechnology, and this widely used in a car, motors, aircrafts, energy devices, or electronics equipment, paint, medicines, packaging, etc. So when you define the different terms like nano cluster, nano colloids, nanoparticles, nano crystals, so these are the different terminologies where we use the nano. So nano cluster is nothing but a collection of units of up to about 50 units in that particular one. Then that is called a nano cluster. So like this is the example here. This is known as a nano cluster, where uh, more than atoms add one by one and create a new nucleus. So that is called a nanocluster. And nanocolloids is a stable liquid phase containing the particles of this 1 to 1000 nanometer range. And colloid particles is one such of this particle. So nanocolloids are widely used in machining purpose. So as a cutting fluids, we just use, because these are the stable liquid phase through which it will not precipitate. So why any nanoparticle is not stable? That is because of the Brownian motion, and it will create a new nucleus, because it attracts the other particles, and when it creates the nucleus, then it will settle down because of the weight. Nanoparticle is nothing but it is a particle size where 1 to 1000 nanometer range, and it should be it could be a nanocrystalline in nature or aggregate of the single crystal or this crystallites. So nanocrystal is nothing but a solid particle in a single crystal in a nanometer range. That these are called a nanocrystals. So why nanoparticles are different from the bulk material? So there are different properties. According to the properties, we just differentiate the nanoparticles from the bulk material according to your magnetic property, mechanical property, optical or biological property or electrical property. So these are the various properties through which you can differentiate of nanoparticle from the bulk material. So each nanoparticle is unique in terms of the physical property and as well as the chemical property. So because each particles is having a different property, but bulk material is nothing but it is showing the overall physical and chemical property. But in nanoparticle, each atoms, we are working in a nanometer range or atomic range. So each atoms or each particles is having a different physical and chemical properties. So several challenges in the nanotechnology. So in the fabrication processes of nanomaterial or nanostructure, first challenge is the how you can overcome the huge surface energy, because this surface energy is affecting on the surface. So it results in enormous surface area to the large surface to the volume ratio, and also ensure all the nanomaterials with desired size, uniform size, distribution is uniform, morphology wise it is not, maybe sometimes it is not uniform, crystallinity wise, chemical composition, microstructure, that all together result in desired physical properties. So prevent nanomaterial and nanostructure from the conquering through either post-world ripening or agglomeration will happen in when you add the nanomaterials in any matrix. So how you can remove that particular agglomeration, that is a challenge in fabrication of your nano composite material. And how you can control the morphology of that particular material, because each particle size, maybe some particles are in a random in nature or some particle are in a spherical in nature. So that is also a more component, and at least one component whatever you have, that you just mix with the nanometer range. So this it consists conductor, dielectric material, whatever the material you have using, the glass also, if you have the uh, nanoparticles of the glass or solid materials, solid lubricants. So it is metals, non-metals. So nano size particles generally embedded in the different matrix. These matrix may be a ceramic matrix, glass matrix, epoxy glass, or polymer matrix. So these are the basic three matrix, and you just add the particulate and make the nano composite material. So when you what are the basic general features of nano composite material, how it is different from the traditional material. So this, in this slide we just, I want to show you some some difference. So nano composite is different from the traditional composite in the smaller size of the particle in the matrix material. That is the basic difference. In traditional, your size of the particulates is larger than the in nano composite. So due to the mixing of a smaller size, it may cause the physical sensitivity also, or higher chemical reactivities of the grain boundaries, because we know all the grain boundaries are having a highest energy in that particular any material. So physical sensitivity means small size effect, quantum confinement effect. Chemical reactivity means higher gas absorption, regrowth, subgaining, assembly, rotation, and orientation. These are the few physical and chemical reactivity in that particular nano composite. So when you mix that nano composite materials, so nano composite can be formed by the blending of inorganic clusters, fluorescence, clays, metals, oxides, or semiconductors with numerous organic polymers or organic or organometallic compound, biological molecules, enzymes, sol gels derives from the polymer. So whatever this material, you just mix it in that particular matrix. So you can see here this how it looks like this dispersed nano composite nanomaterials in that particular composite material. So by adding this nanoparticles, it is application in electrical, magnetical, electrochemical, catalytic, optical, and structural and mechanical properties are improved in some extent. So there are various advantages or limitation of the ceramic nano composite processing when you are working in a ceramic based nano composite. So different methods are used like powder process methods, sol gel process, how you fabricate the composite material, and polymer precursor process, then spray pyrolysis, liquid infiltration, high energy ball milling, CVD and PVD. These are basically used for the composite coating, and then rapid solidification process RSP with ultrasonication. So these are the various methods. So these are methods used in a ceramic waste, and these are the method used in the metal waste nano composite. And these are the methods which is used in a polymer based nano composites. So in this melt intercalation, in situ intercalative polymerization, or pre-polymer form solution, sol gel process. So by these methods, we just fabricate the polymer based nano composite. By these methods, we just fabricate the metal based nano composite, and by these methods, we just fabricate the ceramic based nano composite. And these are further advantages and disadvantages are given. I am not going to into detail in that particular one. So how we are manufacturing the composite material? So we have we just use the binder, we just use the reinforcement, and finally we mix with the binder with the reinforcement, and we will get the composite material. So for various applications. So in this study, this is done by my doctoral student. He just mixed that graphene and multi-wall carbon nanotube nanoparticles in that particularly epoxy glass fiber composite, and then they just perform the testing, mechanical test like tensile, flexural, and impact test, fatigue test. So for structural application, so he just used the vacuum bagging layup technique, because in epoxy based or polymer based, basically layup techniques are used to make the composite. Layup technique means you just keep your lamina, and then you just apply a layer of that particular epoxy or some epoxy, then again you just make some layer. So in this you just pile it up off, and then you just make a laminate. So in vacuum bagging techniques, you just apply some pressure, and you just perform in that laminates. You just go inside in the vacuum, and then it is remove unwanted things, and you can compress that particular different laminas and fabricate a good quality laminates by vacuum bagging techniques. So in this research, I just use the epoxy of this just purchased by Triveni Industry, and mixed uniformly by the 10 to 1 weight ratio. If 10 gram of the epoxy, then 1 gram of the hardener, we just use in that particular fabrication. So this is the composite, and here we just use the 0 degree fibers, 90-degree fibers, 90 degree, and then 45 degree fibers. So these are the different fabricated samples. in that nano composite. So each orientation we just tested for the tensile, compression, and flexural test. So this flexural test is basically performed in that particular 3-point bend test. So we just observe that particular which one gives you the highest tensile strength, highest compressive strength, and flexural strength in that particular cases. So mostly we found that whatever the 0-degree fiber orientation, it gives you the good tensile strength as well as good compressive strength and good flexural strength other from the other orientation. Then also we perform to check the shear load and shear strength, shear modulus, and what is the maximum elongation in that particular composite will happen. Then in that case also we found that the 0-degree laminate gives the better results rather than other laminates. So we also identify the fracture mechanism in that particular different laminates. So this tensile, how it is behave in tensile strength, how it is behave in the compressive, or how it is behave in the that particular flexural test. So after each test, we just see that particular in this tensile test, we just see that particular fiber pull out is there, epoxy matrix also pull out, fiber is damaged, fiber broken, voids also fabrication of the voids inside the material due to the fiber pull out. Then this sometimes the fiber fractures is also happened. So these are the some tensile images, and you can see here the very less damage in that 0-degree. That's why it shows the better uh, tensile property in that particular structural one. Then another thing, compressive load, we just check the compressive strength of that particular different orientation, and then we found that this compressive load is also better than in this case rather than uh, other orientations. So flexural test we performed on 3-point test, and we just tested, and then we just find out that in the 0-degree only the matrix is stripped from 1 to over this, and some lamination is occur, but other is damaged very late. This is a 45-degree laminates, like this is 45, this is 45. Then this gives you that this 0-degree gives you the better result in that particular cases. Then in case of the shear loading, we just observe that how the surface of that particular composite material behaves. So more or less, it is not much more affecting the orientation. And but in this case, you can see that in case of shear, this 45 gives the better results. So this from this study, we just conclude that whatever the laminate we have fabricated, like 45-degree plus minus 45, 90-degree or 0-degree, 90-degree, shows the lower ultimate tensile strength as comparison to the 0-degree fiber orientation laminates. And also this 0-degree laminate shows the maximum compressive strength as comparison to the other composite orientations. And from the microstructures, we just observe that the composite laminates variant orientation is failed due to the debonding of the fiber matrix interaction, fiber pull out, porosity, river flow lines in the matrix, and respectively. Also, we just observe that it is a significant variation in the characteristic of the composite, which would be the strongly influence the fiber matrix bonding. So these are the observation from this results, which I observed by this, and this paper is published in that particular Arabian Journal for Science and Engineering. So now we move to the application of that particular fiberglass or epoxy glass. So you can see that this Boeing 777. So this yellow color shows that particular fiberglass is used. So in aircraft, various application of your composite material. So that testing of each and every composite material, which test is required, that is very important. So selection of the mechanical test, selection of the physical test, what type of the environment you want to use that particular material. So this wisely, if you select, then you will get a good result at last. So like in this Boeing 777, you can see this yellow color, it is showing in a aircraft, and this is made up of by the fiberglass. And other bluish color, you can see this bluish color. So this is either made up by the hybrid composite, or either toughened carbon fiber reinforcement plastics, you just made it. And this is the basic difference. And here you can see that the how this carbon fiber composite in Airbus A380, it is there. So this is the picture how they just modified their aircraft by using the composite material, because it is having a lightweight, and means it is having a good strength and good stiffness. So various parts is where from the various component we made up by the carbon fiber composite. And if we use the composite material, then you can how much 60 weight percentage of the composite material we used in that particular Airbus, and 80% by volume we are using the composite material in Airbus. So this shows that we are mostly moving towards the complete change of the materials to the composite material, because of that better property than the uh, material. And also it is having a lightweight and a metal material. So generally, when you design some aircraft, then this flammability test is very important. So this test you can also perform it as per the ASTM standard. It is given. So industries are performed like ignitability or heat release, smoke release. So these are the few test type, and current minimum acceptance criteria for each test in that particular fabrication of aircraft. That is very important if you are designing some aircraft by using composite material. So mostly according to our aircraft, either that is a passenger aircraft or that is a cargo or baggage aircraft. So we just decide that particular what type of the flammability test we will do it. So basically compartment interior, this FAR is 25.853, and this FAR is for cargo is 25.855. So this how this instrument FR cycle is working. So composite, your whatever the composite you have fabricated, so either fiber or matrix decomposition, then you just see that particular volatility. Then combustion, when you perform CO2 or CO, other gases, smoke, and it can also release the heat. And after this combustion, your heat flux is also very important, and it burns. And then when it burns, this oxygen from fire atmosphere is also taken. So this is the your FR cycle, how it is looks like. And at last it can see how your composite is looks. So this type of the flammability test is very important. So there are various criterias in our various samples. If you are using the various samples also, like polypropylene and some other types of the composite. So it goes to the flammability test, means you just burn it from the bottom, and how much time it will take to burn that particular material. So that is means a standard acceptability test for the plastic material. Other flammability test, fire test in that particular composite material is cone calorimeter or glow wire test. So these are the two other tests which is possibly used in the design of that particular one. So you can see here I am using that particular polypropylene with 30% enough, and we just use the IFR in that particular material. So you can see how these adding the some nano fillers in that particular one, how the material behaves differently. So this test you just check means you can see within 14 seconds this pure plastic, this polypropylene is showing dip by dip. It is also start burning, but you can see it is still it can sustain, but it can also after some time it will burn. So that's why the aircraft interior, that flammability test of that particular aircraft interior or other things, it is very important. So this is UL94B standard test. You can see after this, it will also dip one by one and it will finish and it will still there. And now, even though this test is basically for 60 seconds only, so that is the case. So that is the standard which is given in that particular aviation industry. So other application of your composite material, it is a high speed ferry, then boats, different types of the boats where also we are using the nano composite also. So this light as lighter as much lighter this tennis racket and other things. So we are using the graphite based composite and other graphene based composite in the equipment. So in polo also we just use like this. So in cars also for interior design we just now moving to that towards the nano fiber composites and other things. So this but when you use then it will add the cost in that particular vehicles. Power generation also because the major effect in the cyclic loading over these winds. So this winds is also having the some humidity also sometimes here, and corrosion resistance and other property is there. So we just use the composite material to increase their wear resistance property, corrosion resistance property, high stiffness, high strength. So in that power generation application in wind turbine, we also prefer the composite material. And not this not a end, we also prefer to build our structure and other things. Bridges also we make. This is a honeycomb structure. It will take more strength. So nowadays when design of the aircraft interior, this honeycomb structure in between the two piles plies, we just add the honeycomb structure so that it will take the better means higher load rather than the other plain material. So these are the application. Now just this is the last one. This work is done by my undergraduate student. Here they just fabricate metal matrix composite for the brake application. So here what we'll do, we just fix our base material, copper tin alloy and silicon carbide with a 5-8%. And then we just also more or less fix the binder, aluminum oxide, and then we add the filler and solid lubricant. So these are the nanoparticles, we just graphite and talcum powder. So graphite, you can see this is a flat way structure, and talcum powder, that is a your random base structure. Then we just perform the micro hardness test, because in brake material the hardness test and compressive test is only important. So it is my means when you decide any application, what type of the test is very important in that particular composite, you just decide first, and according to that if you work in that collection of the data, then I am pretty much sure that you will get a good publication in any journal. So that is very important, how you represent the data, and according to that your application, what application you are focusing, and in that particular application how you can be act according to that, how you can present data. In that way you can publish a good SCI journals. So in this brake material, our friction and wear is very important. So we just perform the pin on disc test. So we also perform the this reciprocating test also. So, but we just check it either in break what type of the test is good. So there are several tests. After test, we just characterize it. So you just see here, this is a pin on disk setup. I just made the stainless steel holder to hold our sample brake pad pin, and we just run it for the 1 hour, and you can see the stability of the friction is very good in that each sample. So hardness wise, it will not much vary in all three samples. So these are the sample lubricant. And also
It's
this
1 o'clock.
compressive strength wise, when you increase the talc percentage, here in a sample we just add the only 15% graphite apart from these three things. But in this case, we just add the 10 weight percent graphite with 2.5 weight percent talc, means here no talc, here 2.5 weight percent talc, and here we just 5 weight percent talc. So talc is having a good property in a wear resistance, and also it is having a good property in a compressive test. That's why when you perform the compression, your compressive strength is increases when you increase the talc percentage in the composite. And you can see that particular one after adding this 2.58% talc, you will get a optimum amount of the friction and little bit higher than wear loss, but it can be good as we get the little amount of the friction. So the in the brake material, the friction coefficient of friction is standard as per the ASTM or industrial standard. That is, if your friction coefficient is 0.3 to 2.45, like that in between range, then it is good for that particular one. So optimum friction in brake material, it is required. So after and before test, we just also characterize the surface and through SAM and index, and we found that particular this surface, you can see that there is a very good surface. And only why this, because we use the this surface is the gray cast iron, because in a brake material our drum is made up of by the gray cast iron. Nowadays aluminum is also used, but the gray cast iron is widely used, and that's why in index you can see after test some iron concentration is all iron is also transfers over the surface, and that acts as a lubricant also. So this is the final conclusion from this work. So whatever the metrics we have fabricated, so our compressive strength increases from the 1.6 kilonewton to 2.4 kilonewton, and also sample A, where we are not using any talc, it shows the higher wear resistance property, and sample B, where we are using talc, so it shows the lowest coefficient of friction and optimum wear rate. So that is the observation from this test. And this is the end of my talk. So thank you very much. If you have any uh, doubt and any discussion, you can discuss with me. Yeah, dear participants, if you have any doubt, you can also write in a chat box. No issue. If you have.
Thank you very much, sir, for your wonderful session.
I
And
hope you all enjoy this session. I just try to cover the basics and then some research aspects so that everybody can understood nicely.
yes, sir. It was really interesting, and more interesting things are about the components under research what you have gone through, and very important session, sir. Sir, very good. And if any participants have any questions, you can ask your questions, or else you can put in the chat window.
This Pankaja ji, actually, you are asking about nanomaterial study,
Book.
any book or a book or website. So this nano material study, there is no such type of the book which I have not seen till now, because this is a very wide variety in that particular, and every nano material is behaves differently, like carbon nanotubes or graphene, graphite, MOS2. So this is you can only find out from the research work only, whatever the published data. According to that, you can plan your research. So in composite, basically you just check first thing for any research, either you are in a master's or doctoral. You just first thing, you just identify your research gap. How the you identify your research gap, what is the application you are targeting. So according to your application, you just target that particular application and what type of the test it is required in that particular application. So in that cases, we just perform that particular test. So not in composite material, so many papers is there, and you never found all types of the test in one paper. They can mix. Yeah, you can also mix with the nano material in liquid dielectric. I have performed few tests in powder mixed EDM process. So in EDM oil, I have mixed the particular nano material, and then I perform the machining using the electrical discharge. Then I found that good surface roughness, and it is a high material removal rate. So that I found by using the powder mix EDM. But the problem in that particular powder mix EDM, this nanoparticle is without any surfactant. If you add, then after some time it will settle down because of the Brownian motion. Because what happened, this one atom will come, then it will attract another atom, and then it makes the whole bigger atom nuclei, and then it will go down. So because of that reason, it is settled down. The stability of the nano material inside the liquid is not good without any surfactant. So when you don't want to add any surfactant in any machining, then you will use that rotate continuously that particular liquid, and then you throw out your dielectric over the machining zone. That is my suggestion.
Sir, good afternoon, sir.
Yeah. Good afternoon,
Sir,
Mr.
myself, Dr. Madhusudan, sir.
Yeah, sir. Yeah.
Sir, I have a simple question regarding that flame test you have shown just now.
Yeah, sir.
Sir, for what type of applications we can recommend this flame test, sir?
This is basically used for the aircraft interior, or whatever the body we are manufacturing
Okay.
for aircraft. So that is the flame test is very important
Yes, sir.
in that particular cases,
Yes, sir.
because how much time it will take to finally burn that particular whole cabin,
Yes, sir.
because that is the human safety is more important. So in that cases, mostly nowadays they are more precise in that particular flame test. And aviation industry is also having some guidelines. So
Okay.
if that particular will not pass, then you will not use that particular material for fabrication of cabin also.
Okay. So in that case, as far as result presentation are concerned, can we take the time duration as the assessment, or is there any other?
A standard time duration is like 60 seconds. They have means ABS. I have shown one slide where the 60-second
Yes,
it
sir.
is there.
Yes, sir.
So that is the standard limit, standard time limit. Can I show again if you want?
No, sir, I have seen it. But my doubt is, can we take the time and along with that some residue left out or maybe weight loss as the criteria of outcome to assess the outcome?
That at last we just do it. What is the residue we have, and then what is the weight loss
Okay.
after some time, after 60 minutes.
Okay.
So that's why in third case you have seen that after 60 minutes also it will not burn. So after that, we just take that particular material, how much residue is there.
Okay.
So that how much volume or weight loss is happened in that particular flame test.
Thank you, sir. Thank you for your valuable answer and response.
Actually, this flame test I here I have not seen. This is my colleague was in foreign. So foreign is having a good place labs in that particular composite. So that I have performed. So in IITs also, IIT Kanpur is having this flame test. So in aerospace department, they have the composite lab, advanced composite material lab. So in IIT Kanpur is also they are having this type of the facility. Any further doubts? I think Udayji, no further doubts from the participant
Sir,
section.
yes, Madhusudan sir raised his hand.
But I answered that he is writing the chat box to.
Yes, sir. Yes,
Okay.
sir. It's answered. It's answered.
Okay. Yes, sir. I think there were no more questions. What was the cost of testing of strength TG analysis?
That
Sir,
is
one.
depend on the what type of the means strength is nothing but you have in the lab facility that fractal test, 3 point test, 4 point bending test, then tensile test, fatigue test is there. So and TGA analysis it is required less means it is costly only because we need the crucible and that sensitive crucible is there. So cost is, I think, estimation of the cost is I have not done, but it is costlier. It is not a very cheaper test. But this mechanical test, it is cheaper. So that's why in so many papers, when you search so many papers, the mechanical test they have performed nicely, but other characteristic like flammability test and then TGA analysis and other analysis it is not done by all. So if you want to a good quality paper, then you at least perform all, then immediately it will accept it. Because if you perform all types of the property like absorption property, then what is the porosity test is there, then your all mechanical properties apart from your frictional and wear properties, also you can perform the corrosion resistance. Then in that way you can define each and every aspects of your material. So that is my suggestion. So regarding the cost, it is not easy, but at least you will within a 5 to 10,000 your full work will be done.
Okay.
Any
Any more
any other doubt?
questions from the participants?
Sir, this is Madhusudan, sir. Can I have your mail ID, sir, so that I can?
Yeah, sir. Okay. Just I am typing, sir.
Yes, sir. Yes.
So these are the two mail ID. So bottom one Gmail is my personal mail ID. That is always be there.
Okay. Thank you, sir. Thank you.
So I hope all the participant at least from this presentation you just take away some message uh, from the this nano composite, what is the application of nano composite, and hope you all enjoy this session, and hope you learn also this from this session what are the tests it is important in the aerospace industry regarding the composite material, because this composite material is not a easy task to deliver, because it took around 1 week to 2 week also sometimes. From the basics, different fracture mechanism is there, lamina fracture, classical lamini theory is there, so many things is there.
Yes, sir. Thank you very much, sir, for your wonderful session. And we hope all the participants got more knowledge and insight into the composite materials and all these things. So we, on behalf of Aeronautical Department, MLR Institute of Technology, thank Dr. Jitendra Kumar Katiyar Garu for delivering his lecture presentation in this particular AACTE sponsored FDP. Thank you very much, sir.
Yeah, thank you very much, and thank you very much for patiently listening by the participants. Because
Yes,
without participants, no event will be successful.
yes.
So any event, if you want to make successful, participants are very important. So thank you very much to all participants who are listening. Continuous 1.5 hour, I think so. So thank you very much. Have a nice day to all of you. Thank you.
Yeah, this is the information for all the participants. The feedback link has been shared in the chat window. You can fill your feedback. And the next session is tomorrow, 9:45 a.m. And remaining all the details you'll be getting in the WhatsApp group. So I request all the participants once again to fill the feedback
Sir
forms.
came or Gupta sir is not here.
Sir,
To Gupta sir
yes,
for
sir, sure, sure. We'll convey your wishes,
I
sir.
hope this will be successfully completed.
Yeah.
And also the 62 or 63 number, that is also a very good number. Nowadays, then you will be happy. So remember these points and always be happy and stay healthy. Thank you very much.
Thank you, sir. Even the YouTube link is also shared. And if any participants miss this presentation in between 1 or 2 minutes or 5 minutes like that, so you can just log into this YouTube link and you can like once again hear to the complete presentation of Dr. Jitendran sir. Participants, you can fill the feedback form. It is present in the chat box. And next session will be tomorrow at 9:45 a.m. Only 24 participants have given their feedback up to now out of 64 participants. So other participants also give your feedback. Because the link may expire soon. So I request all the participants to give your feedback at the earliest.
Dr. Sitaraman, sir, it's okay. Whatever name you have given, it's okay. I'll do the needle. Madhusudan, sir, you want to say something? I have unmuted you.
Yes, madam. Sweta, madam.
Yes, sir.
I have a small request for you.
Sir, please.
Madam, the classwork is going on and one side, and you have got all the set examinations in full swing.
Yes, sir.
And apart from that, network issues, sometimes we may miss the session.
Yes, sir.
So, on behalf of all the participants, I request you to consider the genuine cases. Not, I cannot say that out of 2 weeks, if one day present and then asking for certificate
Yes, sir.
may not be a correct claim. But
Yes, sir.
you try to go for a genuine assessment.
So genuinely also we will consider, sir. That's why I'm providing YouTube link.
Sure,
So
madam. Sure.
yeah, you can. You are in the WhatsApp group, sir.
Yes, madam. Yes,
Yeah,
I'm
in
getting
the
the updates.
Telegram. Yeah, in the Telegram, YouTube, everywhere. I'm providing the what do you say, YouTube link. If you are missing, you can see and fill the feedback form if you are in the WhatsApp group. In
Okay.
at least 1 or 2 sessions. If you
Thank
are
you, madam.
coming, if you're coming regularly, 1 or 2 sessions,
Okay.
then you will know that we are having the WhatsApp group, and in that feedback forms are being shared.
Sure, madam. Sure, madam.
That's why, sir, I'm not closing the feedback forms till evening 5 o'clock or 6 o'clock.
Okay, that's fine.
Even I am taking classes. That's why.
Okay. Thank you. Thank you for.
For everyone, this problem is there.
Yes,
But
madam.
still,
Yes.
still we have. We are happy. We are having good participation.
Yes, madam. That's fine. Even today, also morning, first 10 minutes, 15 minutes, I missed it
Okay.
because of this network connection problem.
Okay.
But out of all the questions, one question is what is the title of the topic, today's topic?
Actually, the title of the topic. I mean, I just shared it in the previous day. Yesterday itself, metal matrix composites. Okay.
Okay.
So I'm giving you the answers also, sir.
Thank you.
Put
Thank,
it, but
thank you.
not for the quiz on Saturday. So for
Okay.
quiz, you people have to watch all the YouTube. Even we have to watch.
Okay, madam. Sure. Thank you.
Yeah, thank you very much, sir.
Thank you.
See you tomorrow.
Okay, madam. Thank you. Huh?
I still see only 39 responses. Participants, can you please fill the feedback form? Sandhya ma'am, your problem will be taken care. Shiva sir, can you please stop YouTube streaming?